An introduction to quadratic models. Let's just think of a case where I want to set a ticket price. Okay, a ticket price for an event. And we'll call that, in our case, we'll call it X, just because it'll be easier in Desmos to use an X. And so X is the price. Now, in this venue, suppose my venue holds 100 people. Okay, but I don't know that that's how many that are going to come. And, so we can, that's our maximum that we could have. Venue holds 100 people. Now it's, for now, we could say N, I guess, is the number. And so if I wanted to get my revenue, okay, that's the price times the number. So if I set the price at, say, $15 and all 100 people came, that would be 15 times 100, or $1,500. And so it's that simple, right? We know how to do that. And so I would, in my terms of my variables, I would write X times N. Okay, but say we have from past experiences of various kinds, both of holding various kinds of events in this venue, and knowing about different events in general and what people tend to charge and all that. So suppose we think that for every dollar, what do I want to say here? Yeah, every, well, let's look at, for every, that's what I want to say. Kind of lost what I wanted to say there for a second. Sorry about that. But we think that for every dollar we go up in ticket price, we lose 5 people. Okay, so when you think, so if we don't charge anything, so here's our price X, and our number N. If we don't charge anything, we expect to fill up the place. If we charge $1, we'll lose 5 people, so that'll be 95. 2 would be 90, and 3 would be 85, and so forth. And if I don't quite see my pattern here, because I should notice right? If I look at my slope for this, I go down 5, right? So 90 minus 95 when I go from 1 to 2. 2 minus 1. And so my slope is -5. And there's my y-intercept. And so, what I see is that my n is minus 5x plus 100. Now, I'd rather write that, I think, as 100 minus 5x, but it doesn't really matter. But there is my number. And so now my revenue is, as before, it's x times n, right? So it's my price times the number of people. But now we are guessing a little more information, and so we get x times 100 minus 5x. And this, if I multiply through by the x, I get 100x minus 5x squared. And so here's the idea is in this section, we want to look at this idea of a quadratic. So a quadratic is a model that includes x squared. Now, in particular, what we can have is we could have y equal ax squared plus bx plus c. And so there's the quadratic part, but then we also have our familiar linear part added to it. But now let's look at this problem. The revenue is the price times the number, and let's just put that into Desmos and see what we get. And when we do that, so there's my x times 100 minus 5x, and we get this parabola shape, and we'll always get a parabola shape from a quadratic model. It may be turned up or it may be turned down. This one I'll call turned down. Let's see, I got to put you on pause. Okay, I'm back. So, it'll either be opening down, like the one we see here, or opening up. And so here is that maximum. That would be my maximum revenue. And so that would be at 10. So if I let x equal 10, now actually I could have, a little better way to do this is if I had called this f of x equals, and where that helps me then is I could actually evaluate this just by saying f of 10. And so we see there the 500. But I can also get it just by tapping on that a couple of times with my mouse. And so we see the most we could make is $500 if I didn't charge anything down here. Well, I wouldn't make any money. Even though 100 people would show up, I wouldn't make any money. And if I charged $20, I wouldn't have anybody show up at that point. So because 100 minus 5 times 20 is 0. So my number would be 0. And, I could get other spots in here. I don't know if I can get them to stay there. No. And of course, if I move the mouse a little bit, it changes a lot. But so, I could follow this to get any point along here. But the highest it ever gets, that highest profit is 500, or revenue, not profit, but highest revenue is 500. And so these quadratic models do come up. We're going to look at pretty specific cases, and we're going to use a little bit different, let's see, let me go back here. We're going to use a little bit different representation for it, and kind of like we used the point slope form for straight lines. We're going to use a vertex form for this. But we'll call that good for this video. There's our introduction. Just the idea that this kind of relationship can come up pretty simply, and we're going to look at that relationship in a little more depth.